Final exam study guide, pages 3 and 4. So starting with number 13, working across all 6 of these, we are working on functions f, g, and h. Just have to do the correct operations with them. So g minus f means that I want to take function g first, 2x squared minus 7, and subtract function f, but I need to subtract all of it, so I want to group it, and then work across here. So 2x squared minus 2x. Let's see, the constants are negative 7 minus 5, so negative 12. Okay, 14, g times h. So set up g times h. We have 2x squared minus 7 times negative 3x. Just distribute that back in. We have negative 6x cubed and plus 21x. Hopefully so far so good. F of g, so we're going to take this g function and plug it into f. So I need to start writing function f, then I'm going to insert function g, and then go back to finishing function f. So function f is in blue, function g was plugged in red. Okay, so I just distribute here 4x squared minus 14 plus 5, and that gives me 4x squared minus 9. All right, row 2. F plus g, but now I have a specific number. So the way we handled this was to do f of negative 2. So that's 2 times negative 2 plus 5, which is 1. And then also do g of negative 2, and then we'll just add the results. So g was 2 times negative 2 squared minus 7. So this part would be 4 times 2 is 8, minus 7 is 1. So I do 1 plus 1 equals 2. Okay, g times h. So g of 3 is 2 times 3 squared minus 7. So that's 9 times 2 is 18, minus 7 is 11. H of 3 would be negative 3 times 3. Negative 9. It says to multiply, so 11 times negative 9 equals negative 99. All right. Number 18, f of h. So h will get plugged into f. Let's solve h first so that we know what to plug into f. So h of 5 would be negative 3 times 5. And then that means I need to do f of negative 15. So I have 2 times negative 15 plus 5, negative 25. Okay, so those are our function operation problems. All right, moving into our simplification of radicals. We want to look at the root type and use our perfect list, I guess, to try to break this apart. So I have a square root. I want to think about a number on the squares list that I can use to break apart 32. The first one I come to is 16 if I'm looking for the biggest one. So for my first root, I'll put a 16. Try to divide the variables by 2. So 4 does divide by 2, so I'll keep all 4. 9 does not, so I'll drop it down to 8. And then in the second root, we put the rest of it. So 16 would need to be multiplied by 2 to equal 32. I used up all the x's already, and I do have one extra y. So then, simplifying, square root of 16 is 4. Variables get divided by root index. 4 divided by 2, 8 divided by 2. And then we just leave the rest of this inside a root. Okay, number 20, we have cube roots, and it's also being multiplied, so I do want to condense it into a single cube root first. Much easier to do the problem this way. So negative 16 times 4, negative 64. The x's, there are 11 of them. And the y's, there are 25 of them. Now that I have that set up, I'm going to do it exactly the same way as I did it the last time. I want to look at my cubes list. I do have a 64 on the cubes list, and negatives are allowed for cube roots. So we're good there. The 11 does not divide by 3, so I want to bump it down to 9. 25 does not divide by 3, so I'm going to bump it down to 24. which means I do need an extra cube root. I used up all the negative 64. I just need 2 more x's and 1 more y. Alright, so cube root of a negative equals a negative. 9 divided by 3 is x3. 24 divided by 3 is y8. And then I have my cube root. Alright, number 4, just a single root again, so I can split it. 4th root, 162, 81 is on the 4ths list. 17 does not divide by 4, so I make it 16. 20 does divide by 4, so I leave it 20. And in my second root, which is also a 4th root, I need another 2, right? Because I need to multiply to get to 162. So there's a 2. 17 and 16, so I do need an extra x. I used up all the y's. So 4th root of 81 is 3. Divide x4, divide y5, and then 4th root of 2x. Okay, so we're just dividing variable exponents by root type and using our perfects list to get the numbers. Okay, side by side exponents get added. 1/3 plus 4/3 is 5/3. So that is equivalent to a 3rd root of x to the 5th. 5 does not divide by 3, so I'm going to make it 3 divided by 3, which means I have an extra 2 left over. Cube root of x cubed, 3 divided by 3 is 1, so x times the 3rd root of x squared. Alright, so the powers got dealt with first. Fractional power converted to a root, simplification. Alright, same thing here, subtracting my powers this time. 9/4 minus 1/4 is 8/4, so that's x to the 8/4, which is equal to x squared. Nothing to be done. But if it, let's say it came out to 7/4, right? Then I'd have to do the same thing I did over here and do a 4th root with x to the 7th. So just, it's not always going to work out as nicely as this one did. Alright, number 24. Side by side here, there's no pluses and minuses, so it's not a foiling situation, it's just multiplication. So 3 times 6 is 18. The root multiplies to 48. Can you simplify 48? Yes, there's a 16 in that, so we're going to do 18 times root 16 times root 3. That gives me 48. Root 16 is 4. 4 times 18 is 72. 72 root 3. Alright, bottom row. There's no binomials here. I just want to reduce. So 8/4 reduces to 2. The cube root, 144 divides by 3. And the x's are different by 10. And then I just need to split this. So I need to look on the cubes list this time. I don't want to do the same 16 times 3. Look on the cubes list. You should be doing 8 times 6. So we have 8 here. x10 needs to become x9. And then an extra cube root for a 6 and an extra x. Alright, so cube root here is 2. Times this 2 is 4. 9 divides by 3. And then I have the extra cube root. Alright, number 26. This time I do have binomials, so I do need to multiply like this. Alright, 3 times 2 is plain 6. 3 times root 18, negative 3 root 18. Root 8 times 2 is 2 root 8. And then 8 times 18 is 144. Well, this is equal to 12. Right? So 6 minus 12 is negative 6. And then I have a negative 3 root 18. I think I should simplify that. So minus 3 times root 9 times root 2. Okay? And then this here, 2 root 8, I can simplify that too, because this is going to be 4 times 2. Alright, and then, so I have my negative 6. This is 3 times 3, right? So root 9 is 3 times another 3 would be negative 9 root 2. And here is 2 times 2 is 4, so 4 root 2. And so, combining those, negative 6 minus 5 root 2. Alright, so trying to add those radicals at the end, I did need to simplify them down to be able to see if they were possible to be added. Okay, number 27's got a bunch going on. So, let's simplify this one while we're at it, right, instead of just recopying it. So this would be 4 times 5. And so that's 2 times negative 4 is negative 8 root 5. Over here, I need to multiply this root times itself. So that's going to involve some multiplication. 7 times 7. 7 times root 5 and another one, so minus 14 root 5. And anytime we multiply a root by itself, we just get that number, so plus 5. Okay, we have a 5 and a 49, so we can write that as 54. We have a minus 8 and a minus 14 with the same root, so minus 22 root 5. And that's page 3. Okay, page 4. So we're solving radical equations here. That means I need to undo the root types. So for the first one, simply cubing it will take care of the cube root, which means I need to cube both sides. So the cube and the cube root just negate each other, so I have 7x plus 1. And then 64, subtract 1, and divide 7. Okay, number 29. Square root this time. So if I square, it'll negate the square root. So squaring a square root is nothing. It's just going to be 12 minus x equals x squared. I have an x squared. I need to get a 0 so I can factor this. So 0 equals x squared plus x minus 12. And that factors into x plus 4 and x minus 3. So quick solving chart on this. I get x equals negative 4 and positive 3. Since I had a square root here, I do want to check those. Negative 4 would give me 16. Square root of 16 equals negative 4. That's not true. It equals, in an equation setting, positive 4. So this is not right. 3, though, is good, I believe. 12 minus 3 is 9. Square root 3, we're good there. So x equals 3. So when you have square roots, you do have to just go back and check and make sure if there's multiple answers that they both work. Okay, 30, I needed to isolate the root here before I do anything else. So minus 18 first. And then divide the negative 4. And then square both sides. So that gives me a negated square root, so 43 minus 3x equals 25. Alright, so we'll subtract the 43 over, and we'll divide by negative 3. Let's just go back and check real quick. 43 minus 3 times 6 is 18. 43 minus 18 is 25. Okay, that works out. Alright, inverses. So the concept of an inverse is that x and y switch. So if all you have is coordinates, simply switch them. So all the x's become y's and all the y's become x's. Nope. What we don't want to do is what I just did. It's not about switching signs, it's about switching the locations of each of these. Alright, if we have an equation, we'll put a y in to make the algebra easier. We'll switch the x and the y, and we'll solve for y. So if I add 9 to both sides, and then divide by 2, y would equal x plus 9 over 2. Change it back to inverse notation. Alright, 33, same thing. Get a y first. Switch it to x. And then we'll solve for y. So plus 10. And we'll do a cube root then. So y will equal cube root x plus 10 So f inverse equals cube root x plus 10. Okay, just one thing of note here, if you do have a square, when it comes down to the end and becomes a square root, we'll probably have seen a restriction somewhere in the problem. And if we start with a square root and our inverse is a square, we're going to have to restrict it ourselves to figure out where the vertex is and restrict it from that number. So let's just be aware of that. All right, 34, we're doing some graphing. We have a root. Anytime we do root graphing, we're going to make a movement chart. So we'll identify where it begins and then do movement off of that. So this graph is going to be a left 4 and down 2 as far as shifting goes. So left 4, down 2. Here's my start point. And square root graphs just make a half curve. So it'll be something shaped like this. So my movement chart for square roots, we do our square numbers in the x column so that they're able to be square rooted. So we're going to move 1, 2, and 3. So this 1, 1 is not a coordinate, it's a movement amount. So from the starting amount, move 1 and 1. Go back to the starting amount, move 4 and 2. Go back to the starting point and move 9 and 3. And there's your graph. Domain for these is restricted, because if you look from the left, there's no graph over here. It doesn't start until we get to -4. And then it does go off to infinity on the right. The range has a bottom to it, -2, and that goes up to infinity. And that's a typical domain and range for a square root graph. Now this is listed with no infinities here because one of these is an endpoint. So as x goes to -4, f of x goes to -2. One of these lines, doesn't matter which one, has to be those endpoint numbers. Then the other one could be as x goes to infinity, describing the arrow, f of x also goes to infinity. All right, finally, increasing interval. The whole thing is increasing, but again, it doesn't start until -4. But then it keeps increasing, and decreasing it never does. It is possible that these are reversed. If we have a negative in front of it, we would have to be moving downward. So then it would be the opposite. Okay, last one on this page. Now I have a cube root graph, but the same thing applies at the beginning. I need to figure out the shifting. So the shifting is right 2 and up 1. So right 2 and up 1. Cube root graphs would default to a shape like this. You can follow my cursor here. So we go both ways, and the movement chart for a cube root graph is going to be -8, -1, 0, 1, and 8. I'm using cube numbers now. So -8 would be -2. -1 would be -1, 0, 1, and 2. However, there is a negative in front of this one. So what I really want to be doing is x and -y. So I want to go -8, -1, 0, 1, 2, 0, 1, 8. But I also want to go +2, +1, 0, -1, -2. So I'm just flipping the signs on the y's. This is my actual movement. So from this spot, if I go back 8, I want to go up 2. Okay, and then from this original spot again, go back 1 and up 1. From the original spot to the right 1 and down 1. And then back to the original spot one more time, to the right 8 and down 2. And then I can connect those with as smooth a curve as possible. I'm sure yours will be better than mine in this case because you've got paper and pencil. Okay, cube root graphs are always an infinite domain because we have a left arrow and a right arrow. And they're also always infinite range because there's an up arrow and a down arrow. Not as much to think about with these. As x goes to the right, f of x goes down. And as x goes to the left, f of x goes up. Increasing. This graph's going down the whole way. So none and infinite. All right, that'll do it for page 4.